Okay, now let's actually look at the steps to hypothesis testing for ANOVA. So ANOVA hypothesis testing. So the first step, as usual, is we're going to create our hypotheses. And we've already looked at this before. So our null hypothesis is that all means are equal to each other. The alternative is that the null is false. Another way of saying it is at least one pair of means are different from one another. Our second step is just to select alpha and our sample size n. Then we need to check our three assumptions. 4 is to calculate our test statistic, which we've said is MSA over MSW, and that's going to be an F statistic. And then we either need to follow the critical value approach or the p-value approach. So the critical value approach is that we're going to compare our F statistic to an F critical value with C minus 1 numerator degrees of freedom and N minus C denominator degrees of freedom. Again, we looked how to use that table in the last chapter, but we'll just continue to use Excel. And really, this should say alpha. But if we wanted to use the p-value approach, our rule is the same. So our p-value will be the probability that an F value with C minus 1 and N minus C degrees of freedom exceeds the F statistic that we calculated in our ANOVA table. So then when we form our conclusion, this is all familiar. So if our F statistic is in that rejection region, which we define up here, then we reject the null hypothesis and accept the alternative. Of course, if the F statistic is not in our rejection region, then we fail to reject the null hypothesis. But if we use the p-value approach, it's the same rule as before. So if p-value is less than or equal to alpha, then we reject the null, accept the alternative. But if the p-value is bigger than alpha, then we fail to reject the null hypothesis. So these are all the same rules that we've been following through business step 1 and 2. And then finally, as usual, we should state the conclusion in the context of the problem. So give an interpretation. So there's enough evidence to conclude that at least one of our means are different from one another, or there's not enough evidence to conclude that any of the means are different from one another. So let's go back to our example and actually work through this. So we've already done the heavy lifting the last time we looked at our example, but now let's just formally go through this process. So 1 is our hypotheses. So the null hypothesis, so it's the average from Asia is equal to the average from Europe, equal to the average from North America, equal to mu South America. The alternative is that the null hypothesis is false. And I guess I forgot to say, so this is our ANOVA table. I've just filled it in. These are all the numbers we calculated already. I just wanted to paste it down here, and this time it's typed up. So step 2 is to determine alpha. So let's just set alpha equals to 0.05, and we know that n is equal to 40. Step 3 is to check assumptions. So we know we're good here. We checked this. We checked this in an earlier video. I'll just say checked earlier. But if you scroll up, you'll see whenever we talked about assumptions, we looked at the assumptions for this particular problem. So for our F stat, which was MSA over MSW, we already did this, but this was the 390.83 over 62.76, which we got to be 6.23, right, which is what we have right there. So step 5, we can establish our rejection region. So I'm going to say the rejection region is going to be, so it's where F stat is bigger than F. So we would have 3 numerator degrees of freedom, right? C minus 1, or 4 minus 1 is 3. And then 36 denominator degrees of freedom, so n minus c, 40, 40 minus 4, which is 36. And then alpha is 0.05. So we have f stat bigger than 2.87. Again, I got this value from Excel. Okay, and then 6. So let's go ahead and plug f stat into our rejection region. So f stat is equal to 6.23, which is indeed bigger than 2.87, which is F3 36.05. And therefore, because our f stat is in the rejection region, we reject H naught and accept HA. But if we wanted to use the p-value approach, we would say p-value is equal to 0.002. Right, that's what we have up here. Again, this is from Excel, so don't worry about this particular number right now. And that is less than our alpha of 0.05. So if p-value is less than alpha, we reject the null and accept the alternative. So of course, you can do either or, p-value or critical value. So interpretation, so there is enough evidence to conclude that at least one pair of continents, traffic congestion, is different at the alpha equals 0.05 level of significance. Okay, and that's how we formally go through and do an ANOVA test. So by hand, you need to be comfortable finding the degrees of freedom, calculating mean squared error, f-stat. We're going to use Excel for p-value and the critical value, and same for sum of squares. So the calculations by hand are all pretty straightforward, which is why we're going to use Excel for the harder stuff.